Okay. So last class, we have been discussing about the navigation stack 2 and move it 2. So the video will be, I think video got updated. Yeah, the latest video got updated, I guess. And we have gone through the basics, like how we can, um, I mean, set up the navigation stack to then simulations. Then we have just went through the behavior trees basics. All these things we have done. We have took like almost 3 classes for both the movie 2 and navigation 2. uh, Now we are coming to a new chapter, which is like we already discuss about it, but this is like a discussion kind of session, mainly to show how we can interface the deep learning frameworks into ROS2. Okay, so that is one intention of this class. Okay, and if we get time, we will be like just start an introduction to Docker for ROS, which we already discussed for ROS 1, and for ROS 2, like we will be seeing what are the differences. Okay, so that is the agenda of today's class. So uh, as you know, the deep learning is very famous now. Like there are ChatGPT, there are Bart from Google. So there are multiple models actually playing around for multiple purpose, right? For ChatGPT, in case of ChatGPT, it is like a interface which is having a text based chatting, like a chatbot. So it will be giving a proper response from the internet. Okay, it is trained from the data that we are getting from the internet, so it will be giving that appropriate content. And we have, so I hope you know about another stuff. Maybe this is ChatGPT, and I'm not sure you heard about the Perplexity AI. So ChatGPT like write a code for, I mean, write a code in or ROS CPP or ROS, yeah, RCL CPP node. I mean, I'm just asking in ChatGPT, and it can readily create the thing. And uh, so in the Perplexity, it's the same stuff. So if you just 1 second, yeah. So if you just check, it's like a ChatGPT plus the web. I mean the search interface. So we will get some answers with some reference. So that is the Perplexity. So these models are there, right? So in case of robotics, what are the things that we have to understand? So we can use these.
The screen
Okay,
screen is
okay,
not visible,
okay, okay,
not
okay,
shared, I
okay,
think.
okay, 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 okay. 1 second. Sorry for that. Yeah. So so these kind of models like ChatGPT or Perplexity, all these things, maybe we can integrate to robots. Maybe ChatGPT we can act as a chatbot. Like you can create a robot which is having speech recognition and speech synthesis, and you can put the ChatGPT as the main software. You can create it, and rather than these ChatGPT, all this stuff, we have lot of deep learning models to solve perception problems. Like if you have seen the self-driving cars, you may have seen the detection of objects, then pedestrian detection, then car detection. All these things are also doing using kind of training or using deep learning models. Okay, so in robotics, in this chapter specifically, we are focusing on the deep learning frameworks, packages, and what more? The object detection package, all these things using ROS2. I mean, I'm planning to discuss what are the existing framework, then existing models available that we can interface to ROS2. Okay, so that is the intention. So I can't able to show the demo because mostly these things are difficult to set up in a VMware. We can set it up, but the performance will be that bad. So what I'm planning is to give an idea like what we can do with this. Okay, so first we can start with the ROS2 interface with OpenCV and PCL. I just want to give an idea about it, and after that we can start with the next stuff. Okay, so so we already discussed how we can interface OpenCV and PCL to ROS2. So maybe if you have any doubts, maybe you can simply search for ROS2 OpenCV. You will get some packages like this. It's called CV Bridge. Okay, so CV Bridge is a package in ROS1 and ROS2, which is acting as a bridge between OpenCV and ROS2 image messages. Okay, so like maybe I can show you some. Yeah, so this is how the CV bridge is. Okay, so OpenCV is having a data type called CVMAT, and ROS can send images through ROS image message. I think you may know this, sends messages image. Okay, so this is the ROS message type for sending images. So basically, if you are sending image messages from ROS, it got converted into OpenCV for processing. Okay, because the image message has to convert to OpenCV data type, then only we can use that library for processing that image, because in OpenCV there are tons of APIs to process an image. Okay, so this CV bridge can convert from ROS image message to CVMAT and do the processing, and vice versa, like CVMAT to ROS image message. Okay, so I was just saying like we can do this conversion. Okay, this can be done in Python, C++. You can do that. Okay, so ROS to OpenCV, and also the ROS to PCL. Okay, which is again I can say this is again a bridge program. Okay, it's called PCL ROS. So there is a package called PCL ROS. So that will be again bridging the data from ROS, which is sensor messages point cloud. Okay, which is the ROS data type or ROS message holding the point cloud, which is converting into PCL data type. Okay, which is PCL I think yeah, it is PCL data type. Okay, so this is a program that is doing that job. Okay, so I just introduced because if you want to interface ROS, okay, if it is ROS 1 or ROS 2, basically we need some bridging. Okay, so like imagine if we want to do an object detection. Okay, if we want to do an object detection using OpenCV or any library, maybe some library in Python. Okay, so basically like what we are doing is, in order to detect an object, obviously we need the image, right? So if we are working from ROS, what is the input that we can give? Obviously the sensor image, sensor messages image based topics. Okay, and somehow using this CV bridge we can convert the sensor image message into CVMAT, which is OpenCV format. and from the CVMAT we can convert into the NumPy array. I hope you heard about the NumPy, right? The NumPy. So NumPy is very famous. So you can convert the CVMAT into NumPy. So this NumPy is mostly using in the deep learning frameworks for inputting an image. Okay, so basically these bridge program help us to interface the rows message into NumPy. Okay, so I just want to mention that. Okay, and now what we are trying to see is first is TensorFlow, like how we can interface the TensorFlow library into ROS2. So I hope you heard about TensorFlow, but I can give you an idea. 1 second. So the TensorFlow is, I think it's pretty old. Yeah, 8 years ago, 2015, it got released. This is mainly for machine learning and artificial intelligence. It's already there. The description is already there. Okay, and this is a website, tensorflow.org. It is from Google. Okay, you can see here, and you can program TensorFlow using Python and C++. Okay, so you can train models in TensorFlow for object detection or anything you can use. And this is very important. Like, it's actually developed by Google Brain Teams for Google internal use. Okay, so using TensorFlow we can do a lot of stuff. Okay, so a lot of people are using it, and it is from Google, and mostly TensorFlow I mean using Python. Okay, there is C++, but initially it was Python. Okay, so what is happening in a TensorFlow based code? I mean, if you're using TensorFlow or any machine learning framework, what we are basically doing is we are doing the training and testing simply. Okay, so in the training we have a set of data set, and then we are feeding that data. I mean, we are taking it, extracting the data, and then training it. Okay, training the model, and then we will get the model. Okay, so in the testing phase we are inputting some image or something as the test data, and we will get the response. Okay, so in case of TensorFlow, basically TensorFlow, maybe I can show you a basic example for TensorFlow, so you will get to know how we can integrate ROS2 into it. Okay, so this is the beginner tutorial that you are getting from its tutorial website. Okay, so basically in order to work with TensorFlow you just need to import TensorFlow. Okay, that is the module name. Okay, you have to install all this stuff. Okay, it's basically a single line installation. It is there in their website. So if you're working with Python, you can simply import TensorFlow, and then using that TensorFlow API you can do other stuff. Okay, you can do all these things, and you can do the training, and if you just navigate to the vision, we have the computer vision tab here. So computer vision with TensorFlow. So all these things can be done using the TensorFlow module. Okay, yes. Okay, so yeah, so up to that I think it is okay for you. Okay, so here there is an option for vision, like if you want to do image classification or detection, all the things, like there are example code. Okay, so you can see here using PIL. Okay, PIL stands for Python Image Library. It is loading the image and then feeding into I think it's feeding into the model. Okay, so so what I'm trying to say is that if you're working with Python, mostly the TensorFlow or the PyTorch that is coming. Like all this stuff may be using some Python modules like PIL or OpenCV or NumPy for dealing with images. Okay, and the good thing is that you can convert these data types. Okay, so basically what I am trying to say is that you can import, okay, you can import RCL Python or RCL Py into this code. Okay, if you have, imagine you have a TensorFlow code, you can simply import the RCL Py into it and do the publishing and subscribing, and you can simply subscribe to an image, convert into NumPy and feed into this model. Okay, so that simple it is. Okay, maybe I can show you an example so you will get an idea. There are many modules that many Python repository with this idea. Like this is ROS2 TensorFlow. This is one of the package that I got from GitHub. Okay, so the code is like ROS2 nodes for computer vision task in TensorFlow. Okay, so it's tested in Foxy, and basically if you install the TensorFlow, it only need TensorFlow Slim. Okay, it may not need the full version, and it's basically doing like maybe I can show you the code so you will get an idea. I mean, I'm not showing this for using this, but I'm just showing how to integrate the RCL Py to the TensorFlow code. Okay, so you can see here we are importing NumPy, then TensorFlow, and some ROS2 modules, and basically like this is for detection. Okay, detection. 1 second, let me take the proper one. Yeah, yes, this is this. Okay, so you can able to see this is one of the detection code. So just check the code modules first. So you can see from vision messages, import these message, ROS2 TF core. I mean, these are some library that they have created. Then importing image, okay, ROS images. Okay, and there are some services is created, and there is a subscription that we have mentioned. Like this is for doing the subscription of the image. Okay, so after subscribing to this image, it will be converting the image message into NumPy. Okay, so that is what happening here. And after creating the NumPy image, it will be doing the detection and publishing the detection, something like that. So maybe I can one second, I can just show you that in a slide. 1 second, so you will get a more understanding. Okay, so this is what I meant. You can watch the screen. So we have camera here. Okay, camera, and the camera is plugged into a PC which is running on ROS2. Okay, so we have a ROS2 driver for camera. Okay, so the camera is connected to the PC, and we have the driver, and the driver, the main duty of the camera driver is publishing the image. Okay, so we got the image message, and that image message going to TensorFlow code. Okay, subscribe to TensorFlow code, and then what happening, this subscription of the image, it will be converting from sensor messages image to NumPy. Okay, so that is what happening after the subscription. Okay, and after converting to the NumPy, it will be feeding to the detection module or detection model. Okay, and after getting the after doing the detection, it will have the image out, and it will have the, or it may not have the image out, it will have the detection details. Okay, so the model can give you multiple information like the region of interest of the object, okay, number of objects, one second, and the accuracy, okay, accuracy of detection, okay, or the probability, actually that is much better. Okay, all these things the model can give you. Okay, so after that, what happening is that these things, okay, the detected information is going to, like, it will be adding to the image. So so from the ROI we are getting the bounding box, but you know what is a bounding box, right? If a person is detected, you will get a box around it. Okay, so from the model we will get the details of the box, the dimensions of the box. So after getting the details, we are programmatically drawing the bounding box to the image. Okay, and after drawing it, what is the next step? We are publishing it. Sorry. So this is what happening with most of the deep learning framework. Okay, so it can be in Python, it can be in C++, but whatever the library is, you can write your own interface, because ROS2, if you want to include on the Python code, you can simply import the RCLPy. That's it. So import the RCLPy in the code and import TensorFlow, all this stuff, and you can convert the image type to NumPy or any other things like PIL or any other format, and then do the detection, take the inference from it like the ROI, all this stuff, and then draw into the actual image. Okay, so this is what happening in the in this kind of projects. Okay, so you can see here the detection is the bounding box is this, and the accuracy or probability of the object. So 91 means it is high, like the probability is high that the object is a bottle. Okay, so you can try this, or you can write your own code, because this is not very difficult. You can write a single Python code for doing the detection and all this stuff. Okay, so that is one thing. You will get enough projects, like if you do, like if you just search like ROS2 TensorFlow, you will get multiple projects similar to this. Okay, and yeah, this is a project that we have taken. Yeah, Yeah, I think the same project. So yeah. Okay, so that is what like we can do with the TensorFlow. So the TensorFlow code is pretty simple. I think I have shown to you, right? It is like importing the module and then training the module, I mean training the model, all this stuff. And you can able to run it if you have the Google Colab, which is I mean you can run the code online, okay, and see the result. But I think we need the quota to do it, like if you want to do much training and all. Okay, so I hope you got an idea about the flow of the code, like in order to interface a TensorFlow code to ROS2. Basically, this image conversion is the main thing that we have to do. Okay, yes. Now I'm jumping into the PyTorch. Okay, so for the PyTorch also we can apply the same thing. Okay, PyTorch is the framework from Facebook. Okay, one second. Let me take the PyTorch website. So mostly, like if you want to do some vision based stuff, you can use anything. Like there are many options: TensorFlow, PyTorch, or you can use NVIDIA detection framework, or the YOLO. All these things you can use. So if you check the PyTorch, the installation is easy. I'm focusing on the Linux version. Okay, so they are asking for some not dependency, like some requirements, like 11.8 CUDA version, something like that. So in order to work with PyTorch, you can use the pip install, I guess. Yeah, this is for Choco is for Windows, but maybe if you want to work with Linux, there are options. Maybe I just want to search about that. This is actually showing the Windows installation. 1 second, I just want to change into Linux. And yeah, so this is a command. So if you want to install PyTorch on any of the operating system given here, you can simply select it, and then you can see, like, you can program PyTorch using Python and C++, Java. So this is a command, pip3 install torch. Okay, so this is the command that we are using for installing PyTorch. And after that, like there are two methods. Like in TensorFlow we have the C++ and Python, so they are also mentioning how to install it. Okay, so after installation you can just check the packages like that I'm showing. ROS2 PyTorch, which is some templates node, we can run our detection. Okay, using C++. Okay, mostly maybe if you see the code, you can understand. This is a CPP file, this is a header file. 1 second. So you can see the ROS2 C++ node. You can see it's a class called PyTorch node, and what it is subscribing, it is subscribing to the image message, and there is a image like just I think there is a topic for printing the object detector or something, and in the callback you can see it's printing like we got an image, and after that the image is converting using CV Bridge. So this is what I mentioned, guys. It is converting into OpenCV format, and then that OpenCV is converting into the tensor PyTorch format. Okay, and then it's going for the detection. Okay, and then after doing the detection, it is getting the model is getting predicted. The model is predicted predicting the object it is detected, and it is simply publishing that detected object. That's it. Okay, it is not drawing the bounding box in this example, but that is also doable. Okay, but in this project he simply like included the image, and then converted the image into OpenCV, and then converted into the PyTorch PyTorch version, and then sent to the model, then got the prediction, and then it is getting published. Okay, so if you want to work with the PyTorch and ROS2, it's pretty simple. Okay, it's not that difficult. It's basically like conversion. Okay, so that is one thing that I have to mention. Okay, these two things, and rest of the things are like some familiarization of set of packages from NVIDIA for object detection. Okay, so this is more interesting. Like if you have an NVIDIA based laptop, like the graphics card like 2070, if it is more than 2070, it is pretty good, because NVIDIA Isaac is actually supporting from 2070, I guess. Okay, so there are a lot of packages that is coming from NVIDIA. Okay, so there is a page for that. I can show you that one by one. So you can simply listen to this, like the set of packages that NVIDIA provides. So let me take one by one, and we can have a look onto these packages too. We may not be using these packages all the time, but whenever an application comes, we will tend to use the same. I'm just putting the links, and I will explain one by one. 1 second. Okay, and yeah, I think these 3 links are enough. Okay, so just have a look. So first is I will be starting with, let me see which will be better. Okay, maybe I will be starting from this ROS deep learning repository. Okay, I will share the link. Okay, so this is one repository that I have worked a lot of times. Okay, I have worked with ROS deep learning library, mainly with ROS1. Okay, but the thing is, like for ROS2, it's almost the same. It's got converted into ROS2. That's it. Okay, so so why we need to understand or have a look onto this library. The advantage of using this package is that you can do the object detection, okay, in a much higher frame rate, okay, and without using CPU much. You don't need to use CPU much. You can make use of the GPU. Okay, and you can run this on edge AI device like Jetson. Okay, and also you can run it on the PC as well. Okay, I think we can run it on the PC as well, but I need to check. Yeah, mainly they are saying for the Edge AI device, okay, but I need to check whether it is compatible with PC. But they are mainly saying currently like the Jetson Nano. I have tried it, TX1, TX2, Xavier, AGX, and TensorRT boards. So this is the apt package that we can use in a robot, because most of the robots currently equipped with a nano board or a Xavier or an Orin board. Okay, so the ROS deep learning package mainly doing the same thing that we have already talked about. It is getting the image, okay, and it is having a object detection model, okay, object detection model, uh, and this object detection model is faster because this object detection model is getting converted into a stuff called TensorRT. Okay, so initially that is actually happening. The object detection model is getting converted into TensorRT, which is an NVIDIA specific stuff. Okay, maybe I can show you. So TensorRT is like a free open source Python API and SDK for high performance deep learning, and this is mainly for CUDA. Okay, so it is mainly built on CUDA. So what the ROS deep learning package is doing is that if you are loading some models, okay, for object detection, first it will be converting that model into TensorRT. Okay, so once it convert into TensorRT, it will be much faster than the actual model, because we are doing the parallel processing using CUDA. Okay, so there will be some time it will take, like if you try to run this package, okay, ROS2 deep learning or ROS deep learning, it will take some time to convert the ImageNet or any model that we are using into the TensorRT. Okay, and it will be saved. It will be saved, and then the detection, the processing, it will be less, because all the load is taken by the GPU, and it will be much faster. Okay, I personally work with it, and there are different kinds of application that we can use. Okay, DetectNet, which is mainly for detecting object. SegNet is there. SegNet is using another model which is for segmenting. Not only detection, it can segment the accurate part of the object. Okay, and you can customize, like you can give the model any model that you want. It will be loading it, and mainly it is a ROS2 node, right? So you can feed the image through the camera driver, and the output will be the detection array and also the overlay image. Overlay image means the image with the bounding box. And by default, when you install this package, you will get a ton of the model list. Okay, so you can opt from it. Okay, so you can see the list of models available here. Yeah, so for object detection, this much of models are available: SSD, MobileNet, V1, V2, V3, TAVO. I mean, these models are trained with these COCO classes, which is having the object list. Okay, that is not showing here, but there are 91 objects included in this. And for these models, there is only like person, bag, face, all this stuff. So that is for the object detection, and these are the model name for image recognition. Okay, image recognition like AlexNet, GoogleNet, ResNet, VGG, Inception. We are basically using the Inception. Okay, for the image recognition, and there is semantic segmentation, which is not the bounding box, which is like completely extracting the object from the image. Okay, so maybe I can show you the difference between object detection and semantic segmentation. So this is the semantic segmentation you can see here. Okay, so it is not like simply detecting the object using the bounding box. It is like it is extracting the object clearly. Okay, so you can do that using this package. Okay, there are different models available for semantic segmentation. Then there is pose estimation, which is interesting. Like you can estimate the 3D pose of the body, hand, then action recognition. So all these things are available. Okay, so that's why I mentioned like this is an interesting package that you can look into. Okay, I think it is now only available with the Edge AI devices. I'm not sure they will be porting into the PC later. Yeah, they have a lot of example as well. I'm just sharing it. Yeah, this is it. Okay, so it is mainly based on, I think, called Jetson Inference. Okay, Jetson Inference, I think it's actually a package. Yeah, it's a package in from NVIDIA, and you can do the same stuff using Jetson Inference. Okay, so they basically, the ROS deep learning package is creating a wrapper for the Jetson Inference. So you can see a set of demo for image classification, object detection, training, semantic segmentation, all these things. Okay, so there are multiple examples for C++ and Python. Okay, so that is a good thing about it. You can do with Python as well. Okay, so that will be useful. And from the official website of ROS2 documentation, I mean from the ROS2 documentation, there is a page for NVIDIA ROS2 projects. Okay, so that is again one interesting stuff. So from here you can find a lot of deep learning related projects. Okay, mostly the deep learning related and acceleration nodes. Okay, so this is also you can have a look. Okay, this is mainly using the Isaac-ROS framework. Okay, I think we already have seen this in the last class, I guess. So these package again we can put it in the Jetson AI devices. Okay, and I will say this is using the YOLO V8 and DetectNet. YOLO V8 I think you already know. So they have created a wrapper around these two models, and then they have accelerated it using TensorRT. Okay, so the structure is the same. Like we have the sensor messages image and we are doing some kind of resize or something. Then you have the DetectNet model in the form of TensorRT. Okay, then we are predicting it. Okay, almost the same thing. Yeah, and you can see the benchmarking of this, and the DetectNet and YOLO V8 having two packages basically. Okay, and you can see the setup instruction. Okay, so I think it will be working good for Xavier and Orin, and they are also saying this will be compatible with the x86 machine. So like if you just check, you can see here it will be working with Xavier, Orin. And if you have x86 machine, that is our laptop with an NVIDIA GPU, and the CUDA version should be 11.8 plus. Okay, if you have that, these repositories will be compatible. Okay, all these things, maybe I can share this. So this package, the list of Isaac-ROS packages, some packages are for this deep learning stuff. Other are for like map localization related to navigation and some other stuff. Okay, so we will get tons of packages for this. We already seen, right? And in vlogs it is, let me see, yeah, this is for point cloud. Yeah, this is interesting. This is actually creating the depth image. It is predicting the depth image from the RGB, I guess. I need to just check it. So this is the website I will prefer. Like, you can find almost all the deep learning package from NVIDIA, and you can try it on your PC as well. So make sure you have the CUDA version 11.8. The CUDA will be installing with the driver, the latest driver. Okay, so this is for the pose estimation. Yeah, unfortunately it is showing, yeah, 20.04 plus. Okay, that means it will be working with 22 maybe. I need to check it. I didn't try this set. Okay, yes, so that is the thing. Okay, so that is what I was planning for the object detection using ROS2 and deep learning. And one more package is there. Yeah, so these are all are like deep learning models as well. This is for depth segmentation. The input of this image, this model is depth image. Okay, and it is segmenting based on the depth image. And there is one more thing, which is, let me see, yeah, YOLO V8. I'm just sharing it. So 1 second, guys. So this is again not a package from NVIDIA, but this is like a wrapper around the YOLO V8 framework. Okay, so again, I hope you already heard about the YOLO V8. Creating a wrapper around YOLO V8 is pretty simple because you can code it in Python and C++. So using this command, you can install the YOLO V8 framework. Okay, and this much of lines, using this much of lines, you can do the prediction. Okay, so just import YOLO class and then put the model, and then you can do the prediction. So like we have done in TensorFlow and PyTorch, you can convert the ROS image message into OpenCV or NumPy and feed into YOLO. That's it. So this guy actually done that. Okay, this guy actually done that, and he's having a set of launch file to do this stuff, like for segmentation. YOLO can also do the segmentation and human pose estimation. So you can have a look onto this as well. Okay, so this is a good package to get started with the object detection. Okay, this doesn't require NVIDIA, but I will prefer like any GPU will work for YOLO, I will say. Okay, if it is CUDA enabled, it will be great, but it will work with the AMD graphic card as well. Okay, yes, so I think yeah, that's it about today's class. And next class maybe we can start with the Docker and the continuous integration pipeline. So let me know if you have any question. Like today we didn't have much demos. We were been talking about like this is like an information session. Like I'm just sharing what are the packages that we can use for object detection, and how we can interface if it is not there. Like if you have a like TensorFlow or PyTorch program, how we can interface into ROS2. Okay, so basically that was the main discussion. So let me know if you have any questions, and after that we can conclude. Do you have any question, guys? Hope you are clear with it. It's not a big deal, like we are just connecting the rows to the the frameworks, deep learning frameworks. Let me know if you have any questions.
Do we have any option like this thing can be viewed in RVs or
Yeah,
something
yeah, yeah.
visualization tools in
Yeah. I mean, okay. So see here, these demos are all visualized in RVs. So basically, from YOLO, okay, you will get the object position, all this stuff we will get. Then we can make it as a rows message and visualize it in RVs. So here you can see they got the bounding box and then they draw over the image and they are publishing it. So this published image can be visualized in RVs. And also if we have the point cloud and all, you can even publish the transform. Okay, so using these YOLO V8 rows, you can do all this stuff. So basically, if you are using this project, you can visualize everything in RVs, like pose estimation. This is an interesting package actually. A lot of things that you can do in RVs itself. I mean, visualize in RVs. Okay.
it applicable for TensorFlow library and YOLO only?
Yeah, so for TensorFlow, if you are planning to interface to ROS2, we have to write our own thing. Like imagine you got a bounding box points, you can draw it on an image and you can publish it. Then you can visualize it in RVs, and yeah, so that's how we are doing it. So this is actually a project that is already done by some guys who already publishing these RVs related stuff. I mean visualization stuff. So we don't need to do. But if you are planning to interface a new program, okay, that is I mean your own program, then you have to write the rows functions, or you have to publish the visualization messages to visualize it in RVs. So all these things that we can do actually in the program itself. Okay, you can do the visualization in the program itself. Program itself means you can publish all these markers and all this stuff, and you can visualize it in RVs. Okay. Okay, so now I think we can conclude, and so for the next class we will be discussing the Docker and the continuous integration. So yeah, so that is the thing. So we already discussed Docker and all, but this is like we will be seeing how to work with ROS2 with Docker, and working with NVIDIA Docker, which is quite important nowadays, and how to run Docker and run the GUI stuff. Okay. Yes. So that's it, guys. Thank you for attending. So I will be updating the next class date soon. Okay. Thanks, everyone.